Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Please give me a +1 in the chat, guys, if my voice is clearly audible to everyone and everything is working fine. Then I will share my screen and we'll start discussing the problem of the day for yesterday. That was predecessor and successor in a binary search tree. Okay, hi Rishit and hi to everyone else as well, guys. Hi Victor as well. Very good evening, Victor. So let me quickly share my screen and then we can start discussing the rest of the things. Right. So I'm going to just share my screen. All right. Now let us quickly discuss the problem statement and then we'll move further. Okay. So in this particular problem, we have been given a binary search tree. Okay. So what we have been given is we have been given a BST, that is a binary search tree. And do you know what is the property of BST? So let us say that if I'll take 8 here, okay, let's say if I take 10 here, let's say on the left side I take 9 here, if I take 11 here, okay, then let's say I take something like 5 here, okay, then I have something like 6 here, okay, and then I have something like, let's say, 3 here, okay, then I have, let's say, 4 here, and I have 2 here, right? If this is a particular tree that I'm having, so this is nothing but a binary search tree. Why this is a binary search tree? Because the property of the binary search tree, the basic property is that I can see a lot of people have joined. So guys, please give us a +1 in the chat and hit the like button if everything is working fine till now and you are understanding everything till now, right? Nodes of the left subtree are smaller than the right. Yes. So you can see that if this is the if you consider a particular node as the current root node, okay, of a particular subtree, then all the nodes on the left side, they are lesser than the root value, and all the nodes that are on the right side, they are greater than the root value. Okay, that is what you can observe, right? Similarly you can observe that, let's say if I talk about this particular subtree, okay, which is rooted at 5, then you can see that all the nodes that are on the left side, they are lesser than 5, and all the nodes that are on the right side of 5, they are greater than 5. Okay, so is this part clear? Please write yes in the chat, +1 in the chat. Is the basic property of a BST clear to everyone? Please write yes or no, guys. Please write yes or no in the chat if everyone is clear till now. Are you guys clear till now? Please write +1. Is this basic property clear? I hope that it is clear. Right. Now suppose, guys, that if I am instead of talking about the actual problem, let's talk about one more thing, right? Suppose if I was searching for something, okay, suppose if I was doing a search, and if I was doing a search for the target, let us say that the target was something like this. Let us say that the target was 11. Okay, let's say if my target was 11, guys. Okay, so how would I search it, right? Can I say, guys, can I say, let's talk about binary search as well, a little bit of binary search. So let us say that we had an array, right? Just give me a second. Let's say that we had an array, right? Suppose we had 7, we had 8, we had 9, we have 10, okay, we have 11, we have 12, and suppose we have 13. Okay, suppose the target was that we wanted to search for 13, okay, using binary search. Then what will happen? 10 will be the mid, okay, because when you will calculate the mid initially, when you will mark this as low and the ending as high, then this will be the mid, right? So in that case, if the mid, if you will see what is the situation for the mid, if the mid value element at the mid index, if it is lesser than the target, so is it a good idea to search on the left side if the array is sorted? Yes or no? Please tell me. Please write no in the chat. Now it is not a good idea to search in the left side, so that is why we move our search on the right side, correct? So we say that if it happens that the element at the mid, if it is lesser than the target, okay, then what we do? We do nothing but low is equal to mid +1. We try to search in the right side of the mid till the ending point. So we search, we start searching from here till this point, right? So what we do is we discard the left half. Is it clear to everyone? Please write yes in the chat, guys. Is this part understandable to everyone? Because if the mid guy is lesser than the, if the array is sorted, if the mid guy and the mid guy is lesser than the target, so all the guys on the left side of the mid will also be lesser, so there is no point in searching in the left half. So basically, if the search space was n, so we reduce it to n by 2, it becomes half, right? And again, the rest of the search space is n by 2. Again, you out of that, you will again reduce the half of the search space, so it will become n by 4. Are you getting my point, guys? It will become n by 4, so on and so forth until we reach 1. So that is why when you keep on dividing by 2, so the complexity becomes order of log n. Is that clear to everyone? Please write yes in the chat. Is this part clear? That is why the complexity of the binary search is log n now, because you keep on dividing by 2, so it becomes log n to the base 2, right? That is what happens in the normal binary search. Similarly, for this particular problem now, suppose if I am searching for a particular thing, suppose I am searching for target is equal to 11. So if I am at this particular node, guys, right? Suppose that currently I am at this particular node. So tell me if I am currently at this particular node. So if I'm suppose that I'm searching for 11, right? So should I go and this guy 8 is less than 11. So is it a good idea to go on the left side? Should I try to go on the left side? Please write no in the chat. There is no point in going on the left side. Is it clear to all of you guys? Please write yes in the chat and hit the like button as well. There is no point in going to the left side. Agree, everyone? Agree with me? There is no point that I should go on the left side. There is no point, right? So I should directly go on the right side, because if this 8 is lesser than the target, so all the people on the left side will also be lesser, right? That is the property, correct? So we should go on the right side, correct? Similarly, suppose that if I was searching for something like let's say 4, okay? So if I was searching for 4 and I was currently at this guy 8, so if I was currently at this guy and this guy 8 is greater than 4, so there is no point on going on the right side. There you should go on the left side, because on the right side there will be more greater elements. If 8 is greater than 4, so on the right of 8 all the elements will be more greater than 4, so I should go on the left side, right? This is the basic property. Is this part clear to everyone till now? And then I will come back to the problem statement as well. Okay, is this much part clear to all of you guys? All right, very good. Now coming back to this problem, it says that we have been given a BST with the root node, and we have been given a key. So you need to find the in order successor and the predecessor of the given key. Okay, so if you will have a look at this particular tree that has been given, right? So if the key is 8, so if the key is 8 and you will write this tree, so which value comes just before 8 in this tree? Which value is coming just before 8? It is, I think, nothing but 6 here, right? 6 is coming just before 8. Is that clear? Right? Hi Naikaj as well. So 6 is coming just before 8. Is that clear to everyone, guys? Please tell me. If you will see all the values that are there, so if the key is given as 8, then the value that is just coming just before 8 is nothing but 6 here, right? Please write yes in the chat. Okay, if you will write the in order traversal, so it will be what? 1, then you will write 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6, and then you will write what? 10 and 11. So the value that is coming just before 8 in this tree is nothing but 6 here, right? So that is why the predecessor will be nothing but 6. What about the successor? So which value is just greater than 8? The value that is just greater than 8 that is present in this tree. So if you see, the value that is just greater than 8 is nothing but 10. So that is why the successor of 8 will be nothing but 10. Is that clear to everyone, guys? Please tell me. Is this part clear to everyone? Predecessor and successor, the basic part is clear, right? Predecessor is just smaller than the target and successor is just greater than the target. Okay, is that part clear? Please write yes in the chat, guys. Similarly, if you look for the second test case, so if the key has been given as 11, so predecessor, that is just before, just coming before 11, right? So what will it be? It is here 10, right? Now successor, so if the key is 11, so element that is just greater than 11, so no element is present here, right? So that is why we'll give -1. So what is the way to do it, right? One of the ways to do this problem can be, right, method. There can be two methods, right? So I'll just quickly discuss the method 1 and then I'll discuss the method 2, right? Method 1 is that if you know that if I do the in order traversal of a BST, right, in order traversal of a BST, if I will do, so it is in sorted order, right? In order traversal of a BST is in sorted order, right? So if I'll do the in order traversal of the BST, that will come in sorted order. Then in that array, when whatever key I am having now, so I can find the value just greater than it and just lesser than it, right? Very easily. So that is one of the ways that I can do it. But in that case, what will happen? The time complexity will be order of n, okay, and the space complexity will also be order of n, because you have to store the in order traversal. Is this part clear to everyone? That you can use the in order traversal, and then you for that particular target or key, whatever has been given, you can find the just smaller value and just greater value by iterating through the in order array, right? So the time complexity would be order of n and space complexity would also be order of n. But can we do something better than that? Yes, we can do something better than that. What we can do is we can use the concept of this thing that is nothing but the concept of the binary search approach, right? That is discarding the left half of the right half based on the results or based on the current scenarios. So if you will see here, let's talk about this particular this particular case. So let's say we have the tree. So we have 10 to 2 and then 11 and let's say we have 1 here, we have 5 here, okay, then after that we have 3 here, okay, then we have 6 here, okay, then we have what, we have 4 here, okay, this is what we are having. And suppose that the key that we are looking for is nothing but 8, so we want the element that is just less than 8. So initially we will mark what, we will mark the predecessor as -1, or you can say null or -1 kind of thing, right? Let's say we'll mark the predecessor initially as -1, if the elements are, let's say, positive only. Let me just check. Yeah, so if the initially we'll mark the predecessor as -1, okay, and we'll start from the current node, okay, so we'll start from here. Now tell me guys, if I'm looking for the predecessor, right? So if I am at this particular guy, so tell me, is this guy greater, is this guy what, is this guy greater than the key, or it is lesser than the key? Please tell me. It is greater than the key. Correct, it is greater than the key. So where should I go? I should go on the left side. I should tell my program that, okay, let's go on the left side, because this guy is greater, so I'll not store it in the predecessor, and I'll go on the left side. Please write left in the chat. Don't you think that I should go on the left side? Correct. So I should go here on the left side. Okay, so I will go on the left side here. So I'll go to 2, right? I'll go to 2 because 10 was greater and I'm searching for 8. So since I have to search for a lower value, so I have to go on the left side. Then I go to 2. Okay, when I go to 2, so I see that, okay, this guy is lesser than the key. Okay, so in the predecessor, what I can do is, in the predecessor I'll store this value, and now since this guy is lesser, so I'll move on the right side. So I'll move on the right side, and before that, what I will do is I will store the value, right? Are you getting my point? That if it happens that the current data, right, if the current data, if it is greater than the key while finding the predecessor, if the current data, just a second, let me write it properly, right? If this happens, right, that the current data, if this happens that the current data, if it is greater than the key, okay, then in that case what we do is we can simply say that we'll move on the left side. So we'll say that current is equal to current dot left. That is what we can think of, right? Otherwise what we will do is, if we find something lesser, right, if the current is greater equal to, then we'll move on the left side. Otherwise what we will do is we'll say that predecessor will be equal to nothing but the current data, okay, and we will move our current to the right side. So current is equal to current dot right, you can observe. That is what we are doing here, because initially since we were starting, so we were at 10. So now this data, this is greater equal to the key, right? 10 is greater equal to the key, so we need to go on the left side because the predecessor will not be updated. Initially it was -1, right? So we go to the left, we go to 2. When we go to this guy 2, then in that case what we do is, when we go to 2, then after that it is lesser, so we'll say that, okay, let's store this as a predecessor because this is low. So we'll store this in predecessor variable, and we'll move on the right side. So we move to 5. 5 is also lesser, so we'll store 5 and we'll move on the right side. So what we will do is we'll move here. Now what we will do is we'll be at 6, right? So 6 is lesser, so we'll say that, okay, we want to move again on the right side because we want to move closer to 8. So we'll be at 6 and we'll move on the right side. So when we move on the right side, we reach null. So when the current reaches null, then we stop and the predecessor can be said as 6. Is this part clear to everyone? Please write yes in the chat, guys. Is it clear to everyone present in the session? Is it clear to all of you? Right, that is how we kept on searching, right? If the current data was greater equal to the key, then in that case what we did was we were moving on the left. But if we get some data that is lesser, so we first of all store it and then we try to move on the right side, and that is how we get the predecessor at the end, because we stored 6 and we move on the right side, so the current moves to null, and that is when we stop. Okay, so this much part is, I think, clear, right? So let me just quickly do one thing. Let me write the predecessor code here. Okay, so what I will do is, let's say I'll declare a node. Okay, just give me a second. Node star. Let's say I'll store the I'll declare the current as the root. Okay, then what I will do is I'll say that while the current is not equal to null. Okay, while the current is not equal to null, till that point of time we'll keep on iterating, guys. Okay, and if it happens that the current data, right, if the current data, let's say if it is greater equal to the target that I'm looking for, if it is greater equal to the key, in that case I should move where? I should move on the left side. So current is equal to current left, because I want lower values if I'm looking for the predecessor, right? Otherwise what we will do is we'll simply say that before moving from the node, if we are having a lesser value, so we'll store it in the predecessor. So predecessor will be equal to the current data, right? That is what we are going to be doing. And then what we will say is we'll say that current is equal to current's left. So we'll move on the left side. Is this part clear to everyone, guys? Till now, does it make sense for everybody? Please tell me, guys. All right, everyone is clear till now. Similarly, what about this thing? What about the predecessor? What about the other part? That is the successor. So if you will talk about the successor, right? So let me do one thing. Let me remove this piece of code from here, and let's talk about the successor. So if the predecessor is clear to everyone, they can give me a +1. Now let's talk about the successor also, right? So if you talk about the successor part, right? So just give me a second. If you talk about the successor part, right? So initially, what will happen? Now, successor will be automatically marked as -1, okay, because they have passed it by reference, and the key is 8. So if I'm searching, so I want just greater value, okay. So if I'm currently at this value 10, okay, it should be current is equal to current right. Have I not done it? Okay, yeah, I should do it. Sorry, current is equal to current right. Correct. Okay. Now, when I'm at this guy 10, when I'm looking for the successor is the guy that is just greater. Okay. So when I'm at this guy, so if this guy is okay, so if I'm at a particular guy, now understand one thing. If I'm looking for a successor, so if I'm looking for a higher value, so if it happens that the things will get opposite. If the current data, okay, if it is lesser than equal to the key, so is there any point in searching on the left side? No. So I'll say that current is equal to current dot right. Are you getting my point? Please write yes in the chat, guys. Is this part clear to everyone? If it happens that the node that I'm at, if it is having lesser data or equal to data compared to the key, in that case I want to move to the right side because I want the value that is just greater than the key. So I want to move on the right side. Okay. Otherwise, what I need to do is otherwise, if that is not the case, if it is greater, so what I will first of all do is I will say that simply, first of all, I'll store my successor, and successor will be nothing but the current data. So in the successor, I'll store the current data, and I'll move the current to the left because I want to move to a lower value, right? Because I want the closest one. So I will move on the left side. Okay. I'll store that answer, but I'll move on the left side. So what I will do here is, let's say if I'm at this guy, right? So this guy is greater. So in the successor, I'll store this guy at 10. Okay. And then I'll try to look for in the left side whether I have a smaller guy compared to 10 or not, whether I have a 9 or not, something like that. So I'll move on the left side. Okay. So I have stored 10 and I'll move on the left side. So I move to 2. Since this is lesser, so then the key, so I'll move on the right side. So I'll move to what? I'll move to 5. When I move to 5, then I can say that again it is lesser, so I'll move on the right side. So I'll move to 6. It is also lesser, so I'll move on the right side. So I move to null. So that is when the iteration ends, and we can say that the successor is nothing but 10 here. Is this part clear to everyone, guys? This is nothing but searching only. So we are always discarding the half of the parts, right? So n by 2. So the complex like you can say n by 2, n by 4. So it is nothing but overall time complexity is going to be logarithmic of n. That is nothing but the height of the tree. Is this part clear to everyone, guys? Please tell me. Till now, are you comfortable? Whatever I've told or not? The idea is clear. Intuition part, are you getting where we are getting the intuition part? So again, I'll mark the current at the root of the tree. Okay. Sorry. Yeah. Then what I will do is I'll say that while the current is not equal to null, till that point of time we'll keep on iterating. And what we are going to be doing is, if the current data, right, if the current data is less than equal to the key, then simply what we are going to be doing is we are going to go on the right. We are going to go on the right side. So current right, we'll go on the right side because we want to look for the higher values, right? Otherwise, if we get a higher value, right, so we will say that okay, successor, what is the successor variable? SUC, no? Yeah. So we'll say that successor will be equal to nothing but the current data because it is higher. So we'll store it, and we'll try to minimize this successor, right? Please write MI in the chat. We'll try to minimize this successor. So we'll say that okay, let's try and move on the left side, and it's fine. Suppose that for 8 I have stored the successor as 10. So I'll try to move on the left side to reduce the successor value, right? Because I want the closest successor. I want the smallest successor of 8. So that is why I'm moving on the left side. So current is equal to current left. That is what we can do. And simply in the end, you will return, because in this problem there is no return type. So that is what we have to do. They are passed by reference, so they will be checked automatically. That is what I think about it. So current data, no member is named as data. So is there any mistake that I have done? There is no member named as data here. So like, should I check for something else then? I think they have named it as key, right? Maybe current key. I think they have named this as. So let me write this as key also. And yeah, this will be also key, and this will be also key, right? Now let's try and compile this up to check if it is working or not. It says that key okay, into node star current. What is the mistake here? Have I done any sort of mistakes? Successor is equal to current arrow key. Have I done any mistakes? Can you tell me in the comments, guys? I thought that I have done it correctly, but it is saying invalid conversion from this to this. No, it's needed node. Okay, did I made a mistake somewhere here? I have it at the root. So where is the error? Do we have the capital key? Like, have they used the pre is equal to current key? Na? So that is fine, I think. Predecessor is equal to current key. So I think that is fine. Na? Pre is equal to current? No, no, no. You want to pre. Okay, okay. You have the node. Okay, okay. Sorry, sorry. So since you have the node, na, so you don't want to store that. Okay, okay, okay. Pre is like a node. Okay, okay. So we want to store the node actually, not the value. Okay. So they will check the value themselves. Okay, okay, okay. Sorry. Understood, Ricky. So they wanted to store the values, right? Yeah. So now it is working. Let's try and submit it on the all the test cases. All right. That is why I got mistakes earlier also. Yeah, so this problem gets accepted, right? And if you will see, so again talking about the time complexity, so again always you are discarding the half of right half left half, because suppose the tree is n, so in that case n by 2 it is becoming, right? Because you discard one of the halves, then again n by 4 it will become, so on and so forth till 1. So this is nothing but binary search kind of complexity. So that is why the time complexity is nothing but log n to the base 2, right? So the time complexity is going to be log n to the base 2 for the first and the second, both the while loops, okay, because we are discarding one of the halves, right? Same as binary search. So overall time complexity, you can say, will be nothing but order of log n to the base 2. And since I'm not using recursion or not anything else, so the space complexity is going to be order of 1, because I'm just using variable, right? That is just the current variable I'm using extra. So variable will take order of 1 space. So the time complexity of my approach, optimized approach, is order of log n to the base 2, and the space complexity is order of 1. I hope that it is clear to everyone. Please hit the like button, guys, and give me a +1 if everyone is clear till now. Is everybody clear or not? You can tell me in the chat. I hope that all of you are pretty much clear with this idea, right? So I'll just quickly share the link of this code as well. But I hope that you understood this very clearly, right? And the idea behind this also. So that is why I explained in the starting now how to search for a thing. If you want to search for a thing, if you know binary search, then you can search for the lower bound, upper bound also. So similarly here also, if you know binary search, so you are just searching for the lower bound and upper bound in the BST kind of thing. So predecessor is nothing but the lower bound, successor is the upper bound. So that is what we did here in short. Okay, so yeah, let me just provide the code link in the chat. Right, and again telling you about this time complexity will be nothing but order of log n to the base 2, right? Right, because we are just discarding the left half and the right half, so we are just moving in the height of the tree, right? We are checking one node at a level, right? So overall that will be nothing but height of the tree, and height of the tree is log n to the base 2, you can say, right? So this is the thing. And after this, make sure to hit the like button. Okay, if you have understood this problem and watching the recording, so make sure to hit the like button if you have understood the constructive logic thought process of it, and make sure to comment also that you have understood, right? And subscribe the channel if you haven't already, and share it with your friends as well. Okay, and with that being said, I'll meet you tomorrow night with another problem of the day, least prime factor. So we'll meet with this problem. I'll be solving it tomorrow in front of all of you. I hope that all of you enjoyed today's session, and you learned something new from it. If you did, then please let me know in the comment section. Till then, give me a +1 before we end, and like button as well, guys. Thank you for joining, and keep coding, guys. Keep solving GFG POD every day, and all the very best, guys. Thanks a lot.